All right, so today I have Amin Ahmad, co-founder at Vectara, which, according to the website's tagline, is not just another ChatGPT for your data. And moreover, Vectara is a developer-first API platform for easily building conversational experiences that feature best-in-class retrieval, summarization, and grounded generation that all but eliminates hallucinations. So, Amin, welcome to the Data Exchange podcast.
Yeah, thanks for having me, Ben.
And before Amin co-founded Vectara, he was at Google for over a decade. And his last stint there was at Google Research, where he led design and development of neural information retrieval systems. And today we'll cover search, LLMs, and neural information retrieval in three phases. So the first phase, I would say, is the period all the way up to October 2022. This was right before ChatGPT was released. So
Yeah.
unbeknownst to many of our listeners, actually, there were several startups already working in terms of reinventing and reinvigorating search and information retrieval, including Vectara.
Yes.
And there were, the developments there were basically around neural information retrieval, which was embeddings and vector databases. So, give us a overview of that period right before the release of ChatGPT. It was, I felt it was already an exciting period already, right?
Yeah, I agree. The world had started to see what generative AI systems could do around 2018 forward. OpenAI was, really leading this. They were much less kind of open about releasing models and things at that point. They used to always say that these are too dangerous and they have the potential for fake news and other things like that. Yeah, certainly, I think post-Transformers, post-BERT, you started to see developments kind of trickling out of the big research groups at Google and Microsoft and Facebook. And then around 2020, that year, the same year that Vectara started, I saw a number of other startups getting into neural information retrieval. I was following the generative side a little bit less closely, but if you're aware, in around early 2022, maybe, or late 2021, a company constituted called Character AI, which was specifically focused on the generative side. So yeah, for people who are in the field, this has been building for the last few years. I would say it's been very rapid in its development, and in terms of how quickly it's being commercialized, it's probably a function of the value that it's providing. Because if you look at algorithms like BM25, which were developed in the 1990s for keyword matching, they weren't introduced into the mainstream via Solr until 2014 or 15, if my memory serves correctly. So.
Yeah, and actually, so as I recall, so there were several startups kind of really showing the power of these technologies. Primarily, I think a lot of them, we started talking about these hybrid systems, which combine, like you said, BM25 and some of these neural embeddings, and they were already quite promising. And they ran the gamut. Some were focused on consumer, some were enterprise, right? But what were the key building blocks that were in place at that time?
Well, around 2017, I would say, to my knowledge, the very first zero-shot neural retrieval system for text came out. And actually, I was leading the development of that along with a couple other folks, Noah Constant and Javier Snyder, back in Google Research. By 2020, with the release of Dense Passage Retriever from Facebook, the idea that neural IR had...
So you should define some of these terms, like zero shot and...
Oh, yeah, okay.
In the context of search in particular, yeah.
Actually, I think it's interesting to even just look in the broader context of NLP. Prior to the introduction of Transformers and BERT, NLP used to be tackled on a problem-by-problem basis. You had 80 different problems you're trying to solve in NLP, as a researcher, you would focus on a handful of them and you would develop neural networks that would solve that problem specifically. What made BERT so revolutionary, I think, is that they showed a system that once it was trained, then with very small amounts of fine-tuning data could basically solve any problem in NLP. So you can take that same idea and also apply it to the problem of information retrieval, that a neural network with sufficiently general understanding of how language works can actually perform information retrieval in a very effective way across domains and without retraining. That's the idea of a zero-shot retrieval system. So it's based on machine learning and neural networks, but it doesn't require retraining, which people commonly associate with machine learning as you move from one domain to the next. And dense passage retriever from Facebook in 2020, when it was released, I think made it very clear to the world that there's something very complementary that neural information retrieval provides relative to lexical matching or keyword retrieval systems. But it also became increasingly clear that these two types of systems had, again, they were complementary, that BM25 was very good at retrieving information that neural systems couldn't pull back. And that's where the idea then around, I think...
Can you give us an example of where BM25 shines and neural information retrieval is not as good?
Yeah, so BM25 shines in oftentimes when the query is not an open-ended information seeking type of query where someone's seeking to educate themselves on the topic, but rather they're looking for something very specific that they know is there in the document base and they want to match it. And imagine if you're, for instance, even if you're a chemist and you're looking for a very specific molecular formula or compound, BM25 is going to be very good at that. Neural networks, the way they're trained, they tend to be more forgiving of spelling mistakes, but in some fields, like one letter is the difference between night and day. So any kind of situation where lexical matching comes up, an extreme example is if you're searching through a database of license plate numbers, the match has to be exact. Neural retrieval is not going to help very much over there. So they both have a place, and people started looking for strategies to blend the benefits of both. And one approach is, of course, that you run a lexical search using BM25, for example, and then you run a neural search and you combine the results somehow. And that's usually what people refer to when they say hybrid search. Now, there's other styles of hybrid search.
What would be the UX of that combination? It's same as we normally see, kind of like a list?
Yeah, ideally from an end user's perspective, from someone who's using the API, there's no difference at all. They just get back a ranked list of the best results. That's what you want to do. So the hard work of how to actually do the combination in the background should be handled by the platform.
Now, I know that search nerds spend a lot of time in the actual ranking. So yeah. How do people do the blended ranking the blended result?
That's a good question, and there's many ways to do it. The simplest way to do it is to just take a linear interpolation of the scores from the neural system and the BM25. You run into a problem there, which is that BM25 scores are unbounded, and that creates a problem. The neural system scores are generally bounded, so it's hard to do it reliably, but nevertheless, for as crude of an approach as it is, it does show impressive performance boosts on a wide range of benchmarks. The other strategy, which I've seen commonly employed, which is even simpler but surprisingly effective, is something called reciprocal rank fusion. So you simply look at the position of the document in both result sets and use that to compute its final position in the blended list. And then there's more sophisticated strategies that I've seen explored. There was a research paper out of Google talking about doing like a full hybrid search, which is, the idea basically proceeds like this. Neural ranking involves computing the inner product of dense vectors, dense meaning that most of the entries are non-zero. Dimensionality is between 500 to 1,000 dimensions. If you look at BM25 under the hood, what it's actually doing, it's also measuring vector similarities. It's also performing an inner product. But in the case of BM25, those vectors are sparse. So you can actually visualize a document as having a dense semantic portion computed by a neural network, like the head, and then this very long sparse tail, which is computed by BM25. And if you compute the inner product in that space, you can get even better results. But the problem there is that the infrastructure doesn't exist today that can do that efficiently. So we're approximating it with reciprocal rank fusion and interpolation. But there's the paper from Google Research was called, I think, Efficient Inner Product Estimation in Hybrid Spaces. And once that kind of infrastructure gets out into the open source world, I think we're going to have even more options for doing this better.
You mentioned a key word there, infrastructure, because for those of us who are not deep into this kind of space of search and information retrieval, we associate this as hard, capital intensive problems, right? So, I mean, you hear about Google's infrastructure, all the things they invented from the Google file system, MapReduce, the phenomenal indexing systems that they have, Kubernetes. So what possessed you, I mean, to start a company outside of this comfort zone of having all of this infrastructure?
Yeah, that's a good question. What happened in my case was that after we developed this zero-shot dual encoder for text retrieval, being an engineer myself, my first reaction was not to go and publish. I actually published the results years later in 2019. I went and started finding product teams to work with because to me, the measure of success is that, product team will use it and integrate it. And we were actually quite successful integrating with a variety of product teams across Google, very large ones like Google Maps to, very small experimental projects, probably about 7 or 8 in the course of 2 years. And the experience I gained during that time is that I started to see the patterns for integrating this kind of technology into products. And I got to thinking that it would be very nice to build a platform so that engineers who wanted to build this kind of neural information retrieval into their products could use this platform rather than having to essentially come and engage in a 6-month consulting engagement with the research team at Google. So that was the idea. I think the other idea that I had was, neural information retrieval, maybe the infrastructure.
So this is like the vision there would be like Stripe or Twilio.
Exactly. Stripe or Twilio. You could even imagine like Elastic or Algolia, potentially. And one of the key things is that although the infrastructure underlying neural search is quite different, it looks exotic, compared to like the previous generation of stuff. Ultimately, the effect it has for the end user, an engineer who's trying to integrate search into their application, is that it dramatically simplifies the experience. There's no more stop word list to manage. There's no more synonym list to manage. All of that stuff is being handled automatically inside the neural network, even up to and including searching across languages, searching across modalities. So creating a unified index that contains not just documents, but also images and video clips. All of that can be handled in a very uniform and simple fashion with neural search. With keyword systems, it was extremely complicated to do, and so people just didn't do it. I think that the role of a search engineer at many companies might become, I'm not going to say it's going to go away completely, but it's going to become simplified. And that search engineer is going to be able to accomplish a lot more with these new neural technologies.
So what were the key pieces of infrastructure that made a company like Vectara possible? So now you mentioned obviously all the advancements in modeling and things like this, but what about, I mean, obviously there's more to building a solution like Vectara than just models, right?
Of course. Yeah, that's a good point. So the models lie at the heart of it. If the models were not good at capturing the meaning of text as a vector, none of this would exist. But then once you have the vectors, you need to manage them and organize them so that you can really quickly search for nearest neighbors, given a vector. So for that, you have this infrastructure called a vector database. And you've seen all kinds of companies, probably Pinecone is the most prominent example, but
and then open source projects like Qdrant, Weaviate, Milvus, right? So,
exactly.
and now even Rockset has come in, the creators of RocksDB.
Oh, I did not know that actually.
Yeah, and then obviously Elastic will build something like this. But like you said, at the heart of these systems, the primitive is nearest neighbors, right?
Exactly. So Elastic already has it. It was recently introduced into Lucene. I think it was introduced a year and a half ago into Lucene. Then they upgraded to HNSW as an indexing strategy sometime last year. And even relational databases like SQLite, I think they have something, or no, Postgres has something called PG Vector. Ultimately, I see that vector databases are going to end up merging into existing relational databases.
Sure.
They don't need to exist as a separate piece of infrastructure in most
Or
cases,
or lake houses, right? So
or lake houses. Exactly.
um
Exactly.
but basically, so as you're contemplating starting Vectara, you also notice that the availability of these systems.
Well, in 2020, most of these companies weren't started, but what was there was Facebook AI similarity search, FIAS. It's a fantastic piece of infrastructure. It's open source, beautifully designed, very modular. And so we actually use that as the core of our vector database solution at Vectara.
So I mean, what happened to that? Wasn't there a Google project starting with S Scan? What's the
Scan,
Scan?
yeah.
Yeah.
Yeah, yeah.
So you're Googlers. How come you didn't pick up that project?
Well, again, so Scan was not open source at the time that we started this
Oh,
company.
really?
Yeah,
Really?
yeah. So Google had an internal system, I think, with a
Yeah.
very similar name, which was very powerful. They've never, I think, released that fully to the world. But I think Scan is some sort of a derivative of that. And I might be speaking slightly inaccurately here, but it was not available when we started the company. We could potentially use it, but right now, FIAS is so well written, it's actively maintained. I don't see the motivation.
So I talked to a bunch of the I've had several of the founders of these vector database companies on my podcast. And one thing I noticed is that they all at some point emphasize scale, because
Yes.
scale seems to be a big thing that people are working on in this space. And psychologically, I think that's the 1 billion vector uh number is, we can handle 1 billion vectors is what everyone wants to be able to say. So talk to us about, because you came from Google. I mean, 1 billion is nothing, right? So in terms of documents and stuff. So talk to us about scaling in this world of hybrid search.
I think one thing that when people think about vectorization, they often imagine some sort of compression going on. And if you're turning an entire document into a vector, that's true, but that's not an approach that people are taking that much anymore. You're actually expanding the content in a way because one of these embeddings is anywhere between 500 to 1,000 dimensions. Each dimension is a float 32. So you're talking about 2 to 4 kilobytes for
So,
what
so,
might
so wait. Let's take a step back for our listeners. So I have a whole PDF. So what am I embedding?
Right. That's a good point. So in the past, people have looked at creating a single embedding for the entire PDF. Of course, you're going to lose a lot of information and resolution that way. So what people do instead is they take it section by section, where you can think about a section as maybe a paragraph. And if you think about a paragraph's worth of text, you're talking about maybe 400 to 500 bytes. And now you're going to turn that into a vector that's 2 to 4 kilobytes in size. Earlier versions of vector databases would only run out of RAM. So you can imagine that there were severe limitations to the scale that you could achieve. You needed to quickly go to sharding the index over multiple machines. You had to look at quantization, which is effectively compression of those vectors. Now things have moved forward so that you can actually serve these vector databases efficiently off of disk. And I think for any viewer who's interested in that kind of thing, Microsoft Research is actually really leading the way with that kind of research. I mean, they're showing,
So these
you
are
know,
SSDs, right?
SSDs, NVMEs,
Yeah.
but showing very impressive latencies of 5 to 10 milliseconds latency or less in multi-billion vector data sets off of disk.
But
And
this,
that's
so
Microsoft.
as you point out, this is research at this point.
Exactly. So this is research. It's, I think, rapidly pushing on into the commercial side because it's needed. You can solve a lot of interesting business problems with less than 1 billion vectors. I have not, in theory, Vectara can scale up there. We've in practice only tested it into the low hundreds of millions of vectors. We are able to serve off disk with low latency, which I think is important for a lot of business use cases. So anyway, yes, I think that Microsoft and Google. Yeah, sorry.
The context there, I guess for our listeners is, I believe not many companies have 1 billion documents anyway, right? So, I mean,
exactly. When we're talking about,
is that the reason why you say that you're already providing a lot of value? Even
exactly. Google and Microsoft are trying to embed the entire web. So they need to get to billions, maybe trillions of vectors, who knows? And, I was reading one of Microsoft's research paper. They said, well, we're serving this index off of, a cluster of, 500 machines. That's way out of scope and beyond the needs of a lot of organizations. You can solve, for instance, you can probably take the entire Jira instance of a company and search that much better with vector search. And you're probably going to have, a few hundred megabytes of text in there, even for, medium or large size organizations. So yeah, you can solve a lot of interesting problems in less than 1 billion.
So, so again, going back to our cutoff date, October 2022, is everything we're talking about around at that point text-based? So are people starting to do multimodal search? So this is all the way up to October 22.
Yeah, so I'm trying to think back to the earliest instances of when I saw multimodal search. It's certainly multimodal search predates that. I know in Apple research and Google research, they've been working on it for a while. But in terms of...
But the companies and startups were focused on text, right? Is that...
I would say, so if you look at companies like DeepSet, Haystack, and Gina, these provide frameworks for doing neural IR. And the idea is, you can drop in your own neural network to do the embedding. And I think the Clip models from OpenAI maybe were the first well-known example of multimodal models. They could do text and images. I can't remember which year they came out. Maybe it was 2021. So yeah,
in terms of a solution a developer can use, around going all the way to October 22, it's mostly for handling text, right?
Yeah, yeah, exactly. That's true. I mean, I think sometime in 2022, Roku published a technical blog post in which they were talking about building semantic search using clip models and another system called Universal Sentence Encoder that could do both text and images. But companies like Roku and Netflix and whatnot, these are kind of like, the cutting edge companies. So this stuff is still not widely deployed outside of Silicon Valley, let's say.
So you talked about earlier. You made a point that, okay, so the advantage of these things is you don't have to retrain the models, right? But I know that one of my favorite talks on this topic is a talk you gave.
Oh, okay.
Yeah, where you describe this pipeline, right? So the pipeline for doing this neural information retrieval. So talk to us about this pipeline and what has changed. What did neural models change about the search pipeline?
Okay, yeah, I'd be happy to do that. And the pipeline has changed a lot, and it's continuing to change. So I can even talk about, how LLMs are actually changing the pipeline even further. But at a high level, I think that pipeline that you're referring to was, the life cycle of a query as it comes into an information retrieval pipeline. And all of these 6 or 7 pieces, and I'll kind of give you a brief overview of each one. Each of these has an analog in the classical pre-ML world, and then it's been replaced by something in the deep learning side in the last few years. So the first thing that usually happens with that query is you're going to try and do some determination of the query intent and potentially take advantage of that to either route the query to a different backend or to find that it's very similar to a query that you've already answered, for which, let's say, you have click data and you know what good results are, so you kind of augment with additional known good results. As long as I've been working in the field, that has been done with deep neural networks. I was basically at Google, so deep neural networks have been used for determining query intent. The next stage is retrieval. And in retrieval, you're focused on quickly narrowing down from millions of documents to a set of 50 or 100 documents that probably contain a good answer to that query or are relevant to the query. The documents come out of the retrieval phase, and then you're looking at doing post-processing to improve the quality of the results. So there's two steps, and they can kind of alternate in their order within the pipeline. One of them is re-ranking. So you're going to take a much larger, again, now these are neural models, and all of these were done, if they were done at all, with cruder methods in the past. But the neural models, because they have this much deeper understanding of language, have quickly supplanted the pre-existing approaches within these modern pipelines. So the re-ranker would generally be a deep cross-attentional neural network. Cross-attentional here just means that it can look simultaneously at the query and the relevant portion of the document and give it a more accurate ranking within the final result set. And then for the first page of results, the top 10 results or whatever you're going to show to the user, you really want to read over the document and extract the most relevant snippets. Because as these IR systems have gained the ability to go deeper and deeper into the content of the document, the title of the document in the first paragraph, which is, let's say, what traditional search engines have returned, is not going to be good enough for helping the user understand why this result was returned. After you do the snippet extraction, at that point, there's I'm going to skip over calibration, but what really changed with ChatGPT is the maturity of generative systems. So now you can do some kind of generative task at the end. And examples of generative tasks that you would do you can think of ChatGPT, or there's so many other large language models out there, is something like summarization. Summarize the top 10 results and give me a quick paragraph on that. Or translation. It's another example of a generative task. So that kind of comes at the very tail end of the pipeline, and then the user gets the results with a summary or a translation, etc. Now, this space is still, this diagram of a pipeline is still evolving very rapidly, because there's a lot of new research, for instance, on taking the generative systems and moving them to the front of the pipeline, potentially. So there's a framework called DSP from Stanford, Matej Zaharia's lab, a gentleman, Umar Khattab, I believe. He's investigating the possibility that when the incoming query comes to the platform, the large language model first rewrites it into a sequence of queries that should be executed against the retrieval backend. And it kind of coordinates this back and forth, looking at the results that were returned from the first query, then writing a second query and sending that to the backend, and going back and forth like that, potentially doing multiple round trips to arrive at a final set of results. So now the large language model is not just at the tail end of the information retrieval pipeline, but possibly right at the beginning as well. And you can imagine two different models there, or you can imagine one overarching model that's kind of negotiating the entire process of information retrieval.
So, by the way, for our listeners, don't try this at home, because you have to do all of this in milliseconds.
Yeah, that's ultimately, I think, what one of the advantages of having a production quality platform is going to be, that you get the serverless auto scale. As soon as you try to build one of these things, you do quickly run into issues of scale. And I think one of the things on that front, Ben, is Hugging Face. It's a very seductive place to be, because you have all of these state-of-the-art models available for free download. And teams that go ahead and they download one of those and they drop it into a system like Haystack or Gene AI, that's exactly the problem they run into. They're like, well, wait a second, just producing the embedding is taking 500 milliseconds. And that's a huge problem. And there's a lot of effort and energy that goes into getting smaller and distilled versions of these large neural networks that can run with acceptable latencies in a production setting.
Plus, the general thing, I mean, is focus on your core business.
Yes.
And I guess some people have in the past have used these kinds of things to attract and retain engineers, right? So come work with us because you can build all of this yourself. But now I think we're getting to a point where these things are will become unmanageable. So it's better for you to really, if whatever your core business is, e-commerce, travel, biotech, focus on that. And,
exactly.
And let someone else take care of this. So you open the door to the next period, which is today, November to today. So ChatGPT gets released. So two things. I think, immediately make an impact in the space. One is the change in user expectation in terms of the UX, right? So before, okay, type into a search box, here's a list, that's the UX. Now it seems like people want something more. They want a chat interface, but on the other hand, they want some sort of assurance that the answers they're getting are correct, or you can cite the sources of the answers. But the other thing you open the door to, which I hadn't heard of, is actually putting the LLMs through various stages of the pipeline. By the way, I mean, going back to that pipeline, so the pipeline in itself remains unchanged. It's just that the LLMs may be in different parts of the pipeline, not just at the end.
Yeah, exactly. Because they're so general purpose in their capabilities, the research community is actively exploring how to integrate them into other parts of the pipeline. And again, meeting with some initial success. So I think this is going to be an area that continues to evolve quickly.
So now in this era that we're in today, there's another notion of hybrid, which is this retrieval augmented system.
Oh, yes.
Retrieval augmented models, where you have an LLM, but then you augment it with whatever, a vector database, a knowledge base, right? So some people, I mean, I think are starting to use this as a way to solve the hallucination problem. So talk to us about this notion of retrieval augmented system.
Yeah, it's interesting because, ChatGPT, when it burst onto the scene, it was, it's like its own, it created its own phenomenon, worldwide phenomenon around it. And so if you come from the perspective of an information retrieval platform, you see that the generation is kind of an augmentation of the platform. But when we talk about retrieval augmented generation, it's actually coming from the other angle, that we have these very powerful generative systems, and we're going to augment them with an information retrieval pipeline. So two similar ways, but different ways of seeing the world. The idea here is, if I'm talking to a system like ChatGPT, if anyone who's played with it knows that it will often answer and say, look, my information is only current to my cutoff date of 2021. But what's really valuable is to have a system like ChatGPT that can reason on top of your organization's data. And so you very quickly then arrive at this architecture of what's known as retrieval augmented generation, where for anything that the user is saying to the chatbot is able to respond in the context of what's relevant from the company's own internal knowledge base or documents or whatever they've decided to search over. So you have this initial phase where you go and you retrieve what's relevant. Now, that architecture has existed in the past, but doing that retrieval with a keyword system doesn't give you the same efficacy as if you use neural dual encoders. They're much more flexible in finding relevant information. They provide much higher recall.
So break it down for our listeners. So let's say I'm in healthcare or financial services, right? So I have a knowledge base or vector database I set up, and then I have ChatGPT. A user sends a query. So now there's these two systems. So what happens?
Okay, let's say that I'm a plaintiff's attorney, right? And I want to sit down to the system, and I'm talking now. I'm interested in, there's a particular case that I'm working on. Let's say it's a workplace injury case. And so what we've got in the retrieval system is, or the index, is all of the witness statements, the medical records, all of that stuff related to the case is sitting over there. And so now I start off by asking, well, what happened to what happened to Mr. Jones's arm in this case? The IR system first executes, taking that statement as a query, and is able to, let's say, return a medical record which describes what happens to Mr. Jones's arm with the following language. He suffered second-degree burns to his wrist and elbow where the electrical arc came in and exited. Okay, and that's actually similar to a real example which I saw. And if you notice, like, the word arm is never actually in that description. So keyword search wouldn't retrieve that result, but a neural system can return that medical record. And then on the basis of that medical record, a system like ChatGPT can then summarize the information back to the lawyer. So that's how these two two work in tandem.
So then, if the knowledge base or vector database for the embeddings are, if the query I ask, there's no answer in those systems, what happens? So it just happens that the question you ask, it literally there's no answer in the.
Yeah, so actually large language models, people have been looking very intensely into the question of hallucination. And it seems like large language models often know when they don't know. So they have low confidence in the answers.
No, but in this case, there's two systems, right? So there's the
Yeah.
ChatGPT system, there's the knowledge base. Knowledge base, literally the question you ask is not in the knowledge base.
Yeah, so first of all, the generative system, when it's presented with the bad results, in this case from the IR system, actually recognizes that none of these are a relevant answer and can literally answer with, there's no relevant information here. That's one approach. The other approach is the IR system itself, if it's properly calibrated, will return results below the threshold of goodness. And so you can then know that, oh, there's actually no results for this particular query. And basically stop the process there. So they're two related techniques for basically solving this problem of what if there's no good information. Yeah.
So I alluded to earlier about user experience and millisecond response rates. Now we have these two systems. I'm confident in the IR, in the knowledge base.
Yeah.
If I'm sending something to an API that I have no control over, that could take seconds. Right.
Well, here's the scary part for, I think, OpenAI and other companies is today we're doing this through APIs, but the open source world is moving so quickly with these LLMs, not just releasing Apache and MIT licensed LLMs, but getting them to run quickly on commodity hardware. Then I think in six months from now, definitely in 12 months from now, the discussion is going to be very different. It's going to be much more feasible for organizations to directly deploy LLMs and never have the data leave their premise.
And the advantage of this architecture we sketched out is a lot of the validated answers reside in your own knowledge base or vector database. And you're just using the LLM to do some summarization at the back end. Is that right? Exactly.
So it's essentially you're relying on it to do some kind of reasoning on top of the data in your knowledge base. That's right.
So then at that point, you may not need this 1 trillion parameter model. Maybe you can get by with like a low single digit billion parameter model, right?
I think that's absolutely right. And to what extent you'll be able to get by, I think that's the answer to that is actually being discovered as we speak by researchers. But it certainly seems like models under 20 billion parameters seem to do very well, even with broad general discussions. They can imitate ChatGPT quite convincingly.
So if you control both of these pieces, you're confident you can still live up to the kind of this millisecond or the user experience will still be.
So today we actually stream because of the fact that the generative step is much more expensive and has higher latency. We'll stream the results back to the customer in milliseconds. I think our RP90 is around 120 milliseconds, and then the generated summary comes in a second or two later. But I think that our current latencies are not representative of the latencies you're going to see in 6 months from now. It's going to get much quicker across the industry, not just for us.
So what's the UX in this world? So is it basically an answer with footnotes?
Yes, I think the answer with footnotes, which is what I think Bing has shown, I think that's one style.
It's kind of annoying at some level because now I have to look at the footnotes. I guess before you have a bunch of search results, you can click on them, but then we got used to that somehow. Right.
Once our trust level goes up and the hallucination goes down, our trust goes up that the summary is actually accurate. I think we're going to end up hiding the results and only display them if the user actually requests, clicks into a footnote or something like that. But right now, they hallucinate enough that we just can't trust them, and we need to see the results underneath.
obviously people who search for information search all modalities, right? So there's image search,
Yes.
there's video search. So what's going to happen? Is it all going to come down to one? I ask a question and then there's a response with different kind of modalities.
Yeah. So okay. So now we're firmly in the world of neural IR, and that's a great question. So stitching together results from different backend data sources, potentially searching different modalities, has traditionally been a very complicated and tricky problem to solve. I mean, Google used to have an entire team that would stitch together the results from like news, videos, images, and the web documents all into one cohesive search page. With neural IR, when you have a neural network that can embed different types of modalities and text in different languages into a common embedding space, one of the beautiful things that comes out of that is that all of that different content comes back pre-ranked for you in response to a query. So if I search for blue shoes, I will get the document for blue shoes, followed by some pictures of blue shoes, maybe followed by a document that's just talking about shoes in general. All of that ranking is done by the neural network. So it represents a dramatic simplification technically for the machinery that has to be built to do this kind of multimodal search. And I think because of that, we're going to see these kinds of like search capabilities that have been basically limited to Google and Microsoft in the past becoming pervasive across the industry, and you're going to see it in a lot of different use cases.
So, I mean, for those of us who don't, who aren't in this day in, day out, so we talked about embedding a PDF. How do you embed an entire podcast, which is an hour long, or a YouTube video that's 2 hours long?
Okay, there's two approaches, the simple and the complex approach. The simple approach, which you can do today, is you can do an ASR, and now you can do that with models like Whisper very, very well. And then you take the speech that's been transcribed and you basically index that as text. And again, that's another use case where neural search works much better than keyword search because we speak much differently than we write. And keyword matching is optimized for the way we write, not the way we speak. The more
But you
information,
lose in video that only takes care of audio. There's a lot of visual information as well, right? So
exactly. So that's the more complex, more researchy area, which is how do we produce embeddings from a video? Let's say you're going to have to segment it into, let's say, 1 or 2 second clips. And for each one, produce an embedding that captures more than just what's being said, but also, let's say, for instance, the fact that there's a white and black light hanging over your head.
Or in the case of sports, right? So when exactly did he kick with his left foot and it went out of bounds, right? So yeah.
Exactly. Now, that kind of research has been going on for a number of years at Google. I don't know when the models are going to be out there that you and I can use or a company can use, but I think it's not far off. If it's not there already, maybe in 6 months we're going to all have access to these kinds of models.
So you alluded to this notion of custom foundation models or custom LLMs, which I'm a big believer in because I think that a lot of companies are not going to be comfortable just sending all this data through APIs that they don't control, where their data is being used to possibly improve a model that their competitors benefit from, or they just can't move as fast. They're bound by how fast the API provider can innovate, right? So what's your sense of the timeline is in 6 to 12 months, there'll be competitive models in the low billion parameters that companies can use for domain specific tasks.
Well, just think about the last 3 weeks. What's happened? You had Cerebrus come out with their 7 and 20 billion parameter models, and then a few days ago, Mosaic ML came out with a model which is competitive with Facebook's Llama. Llama is open source, but not free for commercial use, but it's very, very strong. And now we have a company claiming and showing on a number of benchmarks that they've got one just as strong as Llama, but under an Apache license. So we've already got one of the key ingredients now available under an Apache license. So what do we combine that with? Well, look at techniques like LoRa, which allow an average organization with $500 to $1,000 worth of training costs to now fine-tune a Llama-sized model in a day or two on A100s to their specific use case. And you've got the ingredients for, like, as you're saying, very customized models for organizations. And these are going to be, if you look at what's happening on the cloud provider side with the release of Inferentia version 2, for instance, from AWS, the hardware for running these models is getting better and better. So you no longer need to have ML specialists figuring out how to shard your model across different processors and GPUs. And it's like one Inferentia 2 instance can handle models up to 200 billion parameters.
And by the way, there's another class of startups building tools to help companies do this fine-tuning with minimal expertise, basically focusing just on data, right? So
yeah, I don't know. I'm thinking of like any scale, or I don't know if you had some other examples in mind.
yeah. Lamini.
Okay.
One of the things that I think that I guess with great power comes great responsibility, right? So these chatbot or these large language models that are made available through a chatbot interface, they can be jailbreaking is a problem, right? So they can be and I just came across a paper, basically from AI21 Labs, where they have actual theorems. So these are theorems,
Okay.
which basically they show that any of these models can be jailbroken, basically. There's no way to prevent that. Someone will be able to feed something where the response will be something you unintended, right? So it's very hard to prevent that. So with that in mind, I guess right now our discussion is mostly in the information retrieval space, where companies are, someone is asking a question, and then you can carefully kind of hit a knowledge base and then come up with a reasonable answer. So, but it seems like there's also the risk for companies to go venture further than that. In other words, let's expose a general purpose chatbot that that we kind of customize for our own data to our customers, right? So don't you think?
Yeah. I mean, and look, where things are heading actually is towards automated decision making. And there's a very strong financial incentive to go to fully automated decision making, where, like often you hear companies that want to be responsible, like Google.
So define what you mean by that. Does that mean getting rid of McKinsey and BCG?
Well, so companies like Google, who have more or less, in my opinion, been quite responsible in the way they think about rolling out AI, talk about supporting decision makers with this technology, give the decision maker access to more relevant information to make a better decision. But there's another variant, which I don't think the technology is mature enough to be doing yet, which is fully automated decision making. Let the computer decide and make the decision. Now, anyone who's in the field and looks at it knows that that's a dangerous thing to do. But because the financial incentives are so great, I think organizations, especially ones who don't have like a deep technical understanding of the drawbacks of this technology, like you've been pointing out, are going to be rushing to do that. And that's where things could start to get dangerous for society. Because, for instance, in the field of, like, let's say, the insurance industry, if you start to automate who you issue a policy to and who you deny a policy to, you end up with racial bias and things like that in very subtle ways, and it's a huge problem. So I think that's something as a society we're going to have to grapple with.
Yeah. So in closing, so what are 2 to 3 things that you're most excited about that you think will happen in the next year?
Well, I think first that these LLMs are going to become deployable by organizations privately. I think that's going to happen. That's exciting. I think for me, strong multimodal embedders are going to become available. That's something exciting in the information retrieval space. And I think the other thing, and I'm speaking very much as from the Vectara point of view, and the stuff I'm excited about is also just, the hardware for doing inference is just getting better so rapidly. that a lot of the latency concerns that have plagued these kinds of systems are just going to rapidly go away and become a thing of the past.
So elaborate on that last point. Are you talking about specialized hardware or existing hardware? These models we can do inference on existing hardware like CPUs, and or are you talking about a new class of hardware?
So I'm talking about the development of these new class of hardware like TPUs and inferential chips, how fast those are basically improving and then rolling out into the data centers. But then beyond that, thinking beyond Vectara as a company that operates in the cloud, it's the advancement of capabilities at the edge, where companies like Mosaic ML focus. So like how far off are we from the time when a generative LLM can just run on my phone without ever needing a data connection to the cloud or something? I think it's not that far off. I think not as far off as maybe we were imagining.
So this will require tricks that the computer vision people are quite adept at, right? So compression, distillation, quantization. So are any of these things being explored and worked on actively right now?
Yes, to the extent that to what extent they're being explored on mobile devices, I'm less familiar with the answer to that. But certainly, even here at Vectara, we do a lot of model quantization, both at training time and at inference time. So, for instance, going from float 32 to B float and things like that, it's that's been commonplace for many years now.
Yeah. And with that, thank you, Amin. This has been great.
Well, thank you so much for having me, Ben.